Hello students, in this video we'll understand the connection between differentiability and uniform convergence. Let's suppose that Fn converges to f on the interval AB, and Fn prime, so I'm assuming that the Fn are differentiable, and Fn prime converge uniformly to a function g, then f, the limit of the sequence Fn, is differentiable and f prime of c is g of c, what we expect it to converge to. Great, so here's how the proof goes. So proof let C be a point in AB and epsilon be greater than 0. Okay, I'm going to choose a natural number n, so I can first choose n capital such that what? Such that I know these Fn are converging uniformly to g, so I can say that Fn prime of C minus g of C is less than epsilon over 3 if n is bigger than or equal to n capital, okay? That just stems from the fact that these Fn's are converging to this thing g, okay? Now, I also have uniform convergence, so pick m capital and n, of course this is just a natural number, right, and n, such that Fm prime of x minus Fn prime of x is less than epsilon over 3 if m and n are bigger than or equal to this number m. That's again just a uniform convergence. That's the Cauchy criterion for uniform convergence, such as Cauchy uniform convergence of the sequence Fn prime. Good, and so now what I'm going to do is this, and I'm going to build another function over here. So since, and let's choose the maximum of these two things. So I'm going to construct a new thing over here. L is going to be the max of n and m, so that both of these conditions are going to be true once we're past the level L. Okay? And so now, since FL is differentiable, at C, there is a delta such that if x minus c is bigger than 0 and less than delta, then what do we have? We can say that this difference quotient over here, Fn of x minus Fn of c over x minus c minus Fn prime of c can be made less than epsilon over 3 if I wish. Okay? Now we basically have all the components over here. So now what we're going to do is we're going to consider, so on the interval, so if I look at, so if m is bigger than n, so if m is bigger than or equal to m, the mean value theorem implies that there is a point zeta in between, let's just go from x up to c on the interval x up to c on the interior of this interval, of course, right? If that's going to be like this is again the interior of the interval a to c, such that, well, such that what? Such that Fm prime of zeta minus Fn prime of zeta, that's going to be an L rather, not an N, so I want the L over here. So I want to change these N's to L's. Those should be L's over there. L's. Over here, that's going to be an L. It's going to be an L. That's going to be an L. Beautiful. And do I have any more L's I'm missing over here? So there's going to be an L. That's an L also, so we're just getting our n's and l's mixed up. That's what typically happens when we do all these multi-parameters. So let's put that turn into L. It's gonna be an L over there, and these are gonna be, that's gonna be an L as well. So that's gonna be an L right there. L. L. Good. Now we're right. Okay. Is equal to what? Is equal to the difference quotient of these things over here. So it's just going to be f. So fm of zeta is going to be fm m of c minus m of x. So I'm going to have, I have fm of c, fm of x. Now fm of x is going to be negative over here. The fm of x is going to be positive over here. So it's going to be flx minus fmx minus flc minus fmc over x minus c. Okay? All right, good. And so now what can we do? So now I've found this value zeta that's inside that interval over here, and I know that these things over here can be made small. These things over here can be made less than epsilon over 3. So I know that these things over here in absolute value is less than epsilon over 3. Okay, so what's going to happen over here is that the absolute value of this thing, so the absolute value of this thing over here, we know is the absolute value of this thing over here, and since we're past this regime over here, I know that this is going to be less than epsilon over 3. So this whole term is less than epsilon over 3. And so now here's the kicker. What I can do is I can pass to the limit, right? I can let m go to infinity in this expression. If m goes to infinity in this expression, what we have over here is we have f of lx minus f of lc. So this is equivalent over here to flx minus flc over x minus c, and then minus f of x minus f of c over x minus c. Okay, it's less than epsilon over 3 back. So this whole thing over here is less than epsilon over 3. Okay, good. And so now what do? So now we have 3 terms to estimate. So let's estimate all of our terms. So I want to estimate f of x minus f of c over x minus c minus what? Minus g of c. G of c. And so into this absolute value, what we're going to plug in, we're going to plug in many things. We're going to plug in over here. So I'm going to have to fill in this quantity over here. So I'm going to do plus minus this quantity. And then plus minus f prime of L, right? So now what do we have over here? So now this is going to be, I'm having f of x less than or equal to 3 things, f of x minus f of c over x minus c. And then from that, I'm going to subtract off this f of L, f L of x minus f L c over x minus c. Okay. Then I'm going to have to add that in. So I have f L of x minus f L of c over x minus c. And then from this, I'm going to subtract off f L prime of c. And then the last term I'm going to have is I'm going to have plus f L prime c minus g of c. So I have these 3 terms to estimate over here. So now let's think about this. So this term over here is less than epsilon over 3. That's less than epsilon over 3 from this estimate right over here. Assuming, of course, that x minus, that we're where? We're on this interval over here, 0 less than x minus c less than delta. So if we are bigger, so if let's see over here. So if I'm going to put in, yeah. So f prime, good, okay. So as long as we're past a certain regime, so I'm making this estimate. So this is valid as long as x minus c is less than delta, I get this estimate for free. I get this estimate. So this is less than epsilon over 3. What's this less than over here? This and this regime is less than epsilon over 3 by the continuity estimate. And by the convergence of this fn, it can be f prime n of c less than minus g of c is less than epsilon over 3, provided that n is bigger than or equal to n, which is L, it certainly is. So that's less than epsilon over 3. So those 3 things all add up to showing that this is less than epsilon. So if x minus c is less than delta, f of x minus f of c over x minus c minus g of c is less than epsilon. And so what does that prove? That proves that f is differentiable at c, and it proves that f prime of c is equal to g of c. So it just proved that f prime of c is equal to g of c under the uniform convergence assumption. Thank you very much.